All right, good morning and welcome back. Today, we are going to kind of take our calculators and explore how we can use those to help us out, find kind of a more precise best fit line. So last week we did calculate that using our formula for slope and then for point slope form to get that best fit line. Today we're going to use our calculators. So if you do not have access to this calculator, so the one I have right here, if you don't have access to this, you need to, before you move on, make sure we get access to this. You're going to have to pause this, go into Google Classroom, go all the way back. I think back in August, the second thing I posted was a link to be able to get this from the Google Store for free. Okay, so please go take care of that. And if you need any help, please reach out to me. But you will have to have access to this to be able to do the lesson. Okay, unless you have a hard copy of the TI-84. If you have your own calculator, you'll be able to use that. If you've been using the Calculator app, unfortunately, the free version will not allow you to do all the things we need to do. Okay. Now, the other thing you need, make sure you have the calculator reference sheet handy. Pretty much for the rest of the semester, you're going to need to have access to this for the rest, at least until a break when we're doing things in here. So we're going to be using it. So it's in the packet or today's folder. I uploaded a PDF of this. So go in there, open it up, have it either in another tab or download it, save it onto your desktop. You also might want to print that if you're able, or take a picture of it or put it on your phone. Just make sure you have that handy. Okay. Now, today we're going to use our calculator and also the information that's given to us here, this data set, to do some calculations. So it says students were chosen at random to report their absences in days from pre-calculus class and their current grade as a percent in the class. The data is represented in the table. So right here, number one, using the graphing calculator, enter the data into the table. Now to do this, we have to follow these steps. You'll notice the ones with stars only have to be done once per class. So we'll do them the first time on the first problem. On the second problem, we won't have to do it. Now, if for some reason you would close your calculator all the way out, when you open it back up, you'd have to restart. But right here, it says reset the calculator. So I'm going to go, let me close out of this picture so you can see the whole calculator. So I'm going to do second, and then over here with the plus, I'm going to hit memory. Now we're going to do number 7, so reset. And then I have to scroll over to all, and it's on all memory, and I hit enter. And then I choose option 2 to reset it. And notice here it says the memory is cleared. Okay, so we're good. Now, from here, I can go to this next one, enter the data into the table. So stat. I'm going to hit stat, and then I'm going to hit enter because we're already on edit and number 1 edit. So here are my lists. I can fill those in. So I go here, and I'm just going to go right down the list. List 1, I'll do 3, then 15, then 5, then 2, then 24, then 3, then 8, then 6. Now as you go, make sure you're typing those in correctly. So if you make a mistake, it can cause your whole answer to be off. Okay. So now the next list, I'll do 85, 61, 73, 91, 38, 96, 81, and finally 84. Now make sure as you do that they're in order, because if you would accidentally go and get these two like flipped around, it'll cause your whole answer to be different. Okay. So we've entered them in. Now next, it says create and view the scatter plot. So we've put this information in our calculator. Now we want to create and view the scatter plot, and then we're going to describe the relationship, either linear or nonlinear, and either positive or negative. So we look up here. We did step 2, so step 3, create a scatter plot. So I'm going to hit second, y equals, which gives me the stat plots. Now right now, plot 1 is off. I want to turn that plot to on. So I hit enter, and enter again. Do you see it's flashing on the word on? And this is a plot that on the x-axis has our list 1, which we used absences for list 1. On our y-axis, it has list 2, which was the grade. And as you can see, it has the scatter plot option shows. So to view this now, zoom and then number 9. So I hit zoom up here and type number 9. This is the zoom with reference to our stat plot, and it allows us, it will automatically size it so you can see all the different dots, and it's going to create this relationship, or it scales it so that we can see everything. We can see it's linear, and hopefully you guys know it's a negative, okay, a negative correlation. So create and view the scatter plot, describe the relationship. So we said it's going to be linear. Oops, gotta get my pen back. So linear and negative. All right, now question 3 asks, what is the slope and what does this mean? Now in the past, we would have taken 2 points on here. We used y2 minus y1 over x2 minus x1. We found the slope by hand. Now we're going to use our calculator to do some stuff for us. So up here, to find the slope, first hit second. We need to run something on this, a program on it. So second and the 0 gives us the catalog. And then hit the down arrow to scroll down all the way to the D's. So we got to go all the way to diagnostic on. Now, you see my arrow is right beside that. I'm going to hit enter there. Now I have to enter one more time for it to run. So it ran the program and now it says done. So we're good. Now to view it, we'll hit stat calc. Okay, so once again the stat key, and calc's the second option. So I arrow over to it, and then I'm going to choose number 4, option 4. So linear regression, and it has list 1 as the x, list 2 as the y, so that's good. You can hit enter all the way down to calculate, hit enter again. It calculates for us and gets us lots of information. Now, in the past, you guys are used to slope being represented with an m. I don't know why, but for whatever reason, you'll see here it says y equals ax plus b. Instead of putting an m in front, they used an a. So I'm not sure why, but right here, that we know is the same as our m, or the same as our slope. So I'm going to do a equals negative 2.367. And if you put m equals, I understand what you mean, that's fine. But now we want to establish what does that mean in a math sense. So let's put some context to that. So if it's negative 2.367, if you want, you could think of that as over the top of 1. So rise over run, that's the change in the grade. So the grade drops by 2.367% each time there's one more of the x, which is an absence. So for every one absence, the grade is going to drop by 2.367%. Now, let's go ahead and write that. Now, just so we know, that's not like a punishment from the teacher. Okay, that's just saying, based on this data, we are able to calculate that, not that everyone's grade always drops like that, but if we follow the patterns of the data, kind of on average between all of the different people, it appears that their grade is lower as they miss more days. It begins to drop the more they miss. So for each one absence, the grade drops by 2.367%. All right, now number 4 says, what is the equation of the regression line, or the best fit line? So we already have the a, the slope. The b, we're used to that, y equals mx plus b, so the b is still there, 95.656. So all I have to do now is write in y equals negative 2.367x plus 95.656. Okay, and we are done with that. Now let's go to r. What is the r value? We have not dealt with that before. This r value, once again, r squared, we're not going to have to worry about. If you go on to stats, you'll deal with that. R value, in our case, is negative 0.956. So let me write that down, and let's talk about what that means. Oops, not negative 9. This will always be between 1 and negative 1. Okay, so negative, it was 0.956. And if we look up here at the chart on here, That's our correlation coefficient. It shows, is there a strong relationship or not? And since it's 0.956, that's in this range. It is a very strong relationship between days missed and your grade going down. Okay, so it is very strong and it is negative correlation. Okay. Now, if you forgot, we had said it was negative from the start. You can know that based on looking at the graph. But also, if you ever forget, the R value in this case was negative, which tells us it's got a negative correlation. So to put it into words, it is a very strong negative correlation between absences and your grade. All right, we got one more on this question. On this example, number 6 here, it says, use the regression line to predict the grade of a person that has 10 absences. So this regression line we're going to use with 10. We're going to plug the 10 in for x. And then it says, is this interpolation or extrapolation? So first, let's decide the 10. If we go up to our data, the 10 is under absences. The low for absences is 2. The high is 24. So 10 is in between 2 and 24, which means it's in our data set. So it's within the data set. So that is going to be interpolation. It's in between the high and the low. Now, once again, all we have to do is plug in the 10. So y equals negative 2.367 times 10, okay, plus 95.656. And then from here, all we have to do is run that through the calculator. So be careful when you're typing in your negative. If you use the negative on your keyboard right beside the 0, if I hit that, see I'm holding it so you can see which button it uses. It uses the negative sign on the right, the subtraction sign. That will cause a problem if we have that be our leading term here. Okay, so instead delete that. You have two options. Either select the one down here or just hold shift and hit the negative sign. And that gives us negative 2.367 times 10, okay, plus 95.656. We hit enter, and if they miss 10 times, they would have a grade of 71.986%. Okay, sorry, my calculator went away. And if we look up here, the grade is always to the whole number, so we're just going to follow suit with the chart. We'll round this to the nearest whole number, which gives us 72% as our answer. All right, so the final thing we need to do now, if you're following along with the calculator sheet, we need to clear the data. So we need to get rid of those lists so that way we can do another problem. So I'll hit second memory over here, the plus. This one's a little easier, just hit 4. To clear all lists, we just hit enter, and the done pops up. Now what that did, if I go back to stat and to edit, you'll notice these lists, they no longer have any information on them. They are done, they are cleared, which is good because now when I come back to this next problem, I can enter in a new data set. So the following data represents the height in inches and the weight in pounds of 12 randomly selected people at Circle Center Mall in Indianapolis, Indiana. So we're going to do one more of these together. Once again, it says use a graphing calculator, enter the data into a table. So if we go up here, step 1 was the start. We already did that. My calculator stayed open. I don't need to do it again. So step 2, enter the data into the table. So I go to stat, edit. Here's my blank lists, and I can go ahead and just find it and fill it in. So 76, 70, 68. We just type all of this in, being careful to make sure we do it correctly. And if you didn't do the first one with me, I strongly recommend don't just watch this. Type in with me and see if you can get the same answers, okay? Because you need to practice this or else I think in the long run you're going to be in trouble when you have to do it on your own. So I go to the second list. This one's for the weight. I type all this in. And just make sure you're doing it carefully, precisely, so you get the right results. Some of them are going to repeat. That's okay. We had 160 twice in a row. That's fine. Some people have the same weight, and they might even have different heights. That's just how the world works. And then our final one, 273. All right. And so we're done with that step. Next, create and view the scatter plot and describe the relationship. So once again, we want to decide, is it linear or nonlinear? Is it positive or negative? So we go up here. Now the scatter plot has already been turned on. If you're not sure what I mean by that, if I hit second Y, do you see how plot 1 is on? So we don't need to do anything for that. So instead we can just go to zoom and zoom stat. That gives us the view we want. So I hit the 9 button, and now we have this one outlier up here, but zoom stat allows it to kind of show all the dots. So yes, there is one outlier, but for the most part it is linear and it moves in the positive direction. Okay, so number 2 here. It is going to be linear and positive. All right, so step 3 here. Step 3, or question 3, it's asking what is the R value and what does this mean? So once again, we need to calculate that using linear regression here. Okay. So this start thing, we already turned the diagnostic on. I have not closed my calculator, so I'm good to keep going. Okay, so I'm going to go ahead and hit stat, and then I need to move over to calculate. Number 4 for linear regression, and then it's got list 1 and list 2, which we already entered. Calculate gives us this information. So our R value in this case is 0.520. Now we need to decide, what does that mean? So 0.520, it's not as high as our last one. Okay. So first, it's positive, so we know it's going to be a positive correlation, which we already knew that based on the picture. Then we look, 0.520 falls in the second one, moderate. Okay, so it's not as strong of a correlation as last time. There still is some correlation, but it's moderate correlation. Now, part of that's because we all know there's people of all sorts of shapes and sizes. And while height does generally mean they're going to weigh more, it's not always the case. There's some really tall, really skinny people. There's some people that are shorter that weigh a little more. Okay, there are all sorts of shapes and sizes of people. And yes, for the individual, as I continue to grow taller, my weight does continue to go up. But it's not always the case that just because someone's really tall means they're going to be really heavy. So it is moderate. And so if we type this in, or if we write this in, what does this mean? It means we have a moderate positive correlation between the height and the weight. Ooh, that messed up a little bit. Let me fix that. So between height and weight. All right, so our next one. What is the slope and what does this mean? We already found that. Remember, y equals mx plus b. Ours has an a instead, so the slope is 5.018 if I round. So I'm going to put a equals 5.018. Once again, if you put m equals, I understand, that's fine. Now, if we think of that as rise over run, it'd be 5.018 over the top of 1. So the y value, 5.018 pounds increased each time we go 1 inch taller. And once again, that's not saying that's the case for all of these individuals if we studied them as they grew. But it's saying as we look at this data as a whole, that's kind of our general prediction of what is occurring. Okay, so for every 1 inch increase in height the weight increases by 5.018 pounds. All right, we're just about done here. This next one's part 5. It says, what is the equation of the regression line, or our best fit line? So we already have the slope. Here's the y-intercept, b, just like we're used to. So I just have to write that out. Y equals, we already said 5.018. I'm going to put an x. Now it's plus the b, which in our case is negative, so minus 158. Oops, let me write that better. So minus 158.469 if we round. As you can see, 0.469. Next is 3, so we round down. Okay, so this is taken care of. Now on to the last step. Use the regression line, which we just wrote here, to predict the weight of a person that is 5 feet tall. And then it says, is this interpolation or extrapolation? So first thing, they're 5 feet tall. We need to put that in inches to help us out. Okay, because 5 feet we can't type in. So 5 feet, just do 5 times 12. We get 60 inches. So 5 feet tall is the same as 60 inches. So now let's go check, where does that fall in our chart? So the low here is 62 here. The high is 76. So is 60 between 62 and 76? Hopefully that's easy. No, it is not. It doesn't fall within our data set. So because of that, this is known as extrapolation. Now it's very close. It's not that far outside, but it is still extrapolation. All right, so now let's use the regression line to predict it. So we're going to plug it in here for x, and we're almost done. Y equals 5.018. Instead of x, I'm going to put the 60, then minus 158.469. So we do 5.018 times 60 minus 158.469. I hit enter, and I get 142.611. Now that is how many pounds they are. They're 60 inches tall. Now let's go back up here, and the weight is always to the nearest whole number, so I'll round it to the nearest whole number as well, and we'll get 143 pounds as our final answer. So don't forget, if you're going to do the It's Learning assignment, which I recommend, just go and do that right now while it's still fresh in your mind. But before we could start the next one, to finish this out, go ahead, clear the list. So we're going to hit second, memory, and then choose option 4, and then just hit enter, and now your lists are cleared. If we go look, they're cleared and ready to go for the next one. Okay, so if you guys need any help, please let me know. Hope you guys have a great day, and please reach out, continue to get tests and missing quizzes done. Bye.